Hello, and welcome to my video on upper and lower bound calculations. Before you watch the video, make sure you have a pen and paper ready to work through the answers, along with your calculator, as all the questions are calculator questions. You will also need to be able to work out error intervals, so please watch my previous video on error intervals, see the link in the description below. I will work through a series of worked examples to show you how upper and lower bounds are used in calculations. Some of the questions are exam-style questions, and some require knowledge of other topics such as geometry. Let's start with question 1. Pause the video whilst you read the question and calculate an error interval for V and R. Attempt the rest of the solution if you are able. Resume the video when you are ready to see the full solution. You are given the formula to work out the current in a circuit, I equals V divided by R. First of all, as both V and R have been rounded to three significant figures, we know that we need to write down an error interval for each of these. We want to calculate the upper bound for the current, the largest value it can be. The current I is equal to the fraction V divided by R. How do we make this fraction as large as possible? Just for a moment, consider two numbers, 8 and 2. If we write 8 divided by 2, we get 4, and if we write 2 divided by 8, we get 0.25. So, to get the largest possible fraction from two numbers, we need to divide the larger number by the smaller one. This is how we find the upper bound for I. We divide the upper bound of V by the lower bound of R. The final answer is that the upper bound of I equals 17.6 amps to three significant figures. Moving on to question 2. Pause the video whilst you read the question and calculate an error interval for the number of miles traveled and the amount of fuel used. Attempt the rest of the solution if you are able. Resume the video when you are ready to see the full solution. You are given a formula for the fuel consumption for a journey as being equal to the number of miles traveled divided by the number of liters of fuel used. As both the distance and the amount of fuel used have been rounded, we need to write error intervals for both of these. Let's call the distance d, and the number of liters of fuel consumed, L. We want to calculate the lower bound for the fuel consumption, the smallest value it can be. The consumption is equal to the distance d, divided by the fuel used, L. To get the smallest possible fraction, we need to divide the lower bound of d by the upper bound of L. The final answer is that the lower bound for the fuel consumption is 8.68 miles per liter to 2 decimal places. Question 3 is an exam-style question. Pause the video whilst you read the question and calculate an error interval for the panel length and the length of the garden. Attempt the rest of the solution if you are able. Resume the video when you are ready to see the full solution. What you need to calculate here is the upper bound for the number of fence panels, as the question states that Lauren needs to be certain there are enough panels. We start by calculating the bounds for the length of the panels, and the length of the garden, as both these values have been rounded. The upper bound for the number of panels is the upper bound of the length of the garden, divided by the lower bound of the length of the panel. We need to round this number up to the next whole number. So, the minimum number of panels that Lauren should buy is 25. Question 4 is an exam-style question that combines geometry with error-bound calculations. Pause the video whilst you read the question and calculate an error interval for the length, AH. Attempt the rest of the solution if you are able. Resume the video when you are ready to see the full solution. You need to find the length of an edge in terms of the given length, AH. The easiest way to do this is to find AH in terms of the edge length and then rearrange the equation so that the edge length is the subject. I will take you through this step by step. First of all, let the length of an edge be A. From Pythagoras in the diagram, AH squared is AF squared plus FH squared, so A squared plus FH squared. Also from Pythagoras in the diagram, FH squared is equal to EF squared plus EH squared, so 2A squared. Hence, AH h squared is a squared plus 2a squared, which is 3a squared. Square rooting both sides of this equation gives a h equals root 3a. Rearranging gives a equals a h divided by root 3. The upper bound of a is given by the upper bound of a h divided by root 3. A h is correct to the nearest millimeter or 0.1 centimeters. Let's write down the error interval for a h, then we can find the upper bound for a. Note that in the final answer, the upper bound for the edge length a, we write down all the decimal places on our calculator, we do not round the answer. Question 5 is a different style of question where you are asked to work out the value of v to a suitable degree of accuracy using bounds. Pause the video whilst you read the question and calculate an error interval for a and b. Attempt the rest of the solution if you are able. Resume the video when you are ready to see the full solution. The way to tackle these questions is to work out an upper and a lower bound for the value, in this case v, and then see if they agree to a particular number of decimal places or significant figures. If they do, then this is the suitable degree of accuracy and the reason for your answer. To find the upper and lower bound of v, we need to first write down the error intervals for a and b. We can use these values to calculate the upper and lower bound for v so that we can compare the values. The upper bound of v is the square root of the upper bound of a, divided by the lower bound of b. The lower bound of v is the square root of the lower bound of a, divided by the upper bound of b. Looking at the upper and lower bounds for v, can you see that they both round to 1.08? So, the answer is v equals 1.08 to 2 decimal places or 3 significant figures, the degree of accuracy and hence, the reason for our answer. Question 6 is another question where you are asked to work out a value, in this case the volume of a cuboid, to a suitable degree of accuracy. Pause the video whilst you read the question and calculate an error interval for the cuboid measurements. Attempt the rest of the solution if you are able. Resume the video when you are ready to see the full solution. You need to work out an upper and a lower bound for the volume, and then see if they agree to a particular number of decimal places or significant figures. If they do, then this is the volume of the cuboid to a suitable degree of accuracy. The length, width and height of the cuboid have each been rounded to the nearest centimeter, or 0.01 meters. To find the upper and lower bound of the volume, we first need to write down the error intervals for the length, width and height. The upper bound for the volume is calculated by multiplying all the upper bounds of the measurements together, and the lower bound by multiplying all the lower bounds together. Let's use the values from the error intervals to calculate an upper and lower bound for the volume so that we can compare the values. Can you see that both the upper and lower bound for the volume round to 0.1 meters cubed to 1 decimal place, or 1 significant figure? Hence, the volume is 0.1 meters cubed to 1 decimal place or 1 significant figure. Moving on to question 7, the most complex question we have faced so far. You are asked to calculate the average speed of a train by considering bounds. Pause the video whilst you read the question and calculate an error interval for the journey time in hours and for the distance in miles. Attempt the rest of the solution if you are able. Resume the video when you are ready to see the full solution. You need to calculate the upper and lower bound for the speed, then see if they agree to a particular number of decimal places or significant figures. If they do, then this is the average speed of the train. Remember that speed is given by distance divided by time. Let's call the length of the train's journey, or the distance, d here, and the time taken to complete the journey, t. The length of the train's journey and the time taken have each been rounded. To find the upper and lower bound of the speed, we first need to write down the error intervals for the distance and the time taken. Note that as the degree of accuracy for the time has been given in minutes, we need to convert the time to minutes initially, and then divide by 60 to convert back into hours as we need the speed in miles per hour. We can use the error intervals for the distance and the time to calculate an upper and lower bound for the speed of the train. Can you see that both the upper and lower bound round to 90 miles per hour to 1 significant figure? Hence, the average speed of the train is 90 miles per hour to one significant figure. Thank you for watching my video. I hope you now know how, and when, to use upper and lower bounds in calculations. If you have found the content useful, then please consider subscribing to my channel.